Hi, this is Clay Hearn with Applied CAX with an overview of automation and productivity enhancements in Simcenter STAR-CCM+. Simcenter STAR-CCM+ is the flagship multiphysics CFD tool in the Siemens Simcenter portfolio. It achieves best-in-class capabilities by focusing on these four pillars. The first pillar is to model the complexity, make sure that you can capture the detailed geometry and accurate physics. The second pillar enables you to explore the possibilities. This is done through automation to go from a single design to hundreds of design points. You can find the optimal design to drive innovation and stay competitive. The third pillar is about speed, making sure you can quickly set up your problem, find a solution within hours and not weeks. And finally, in the fourth pillar, Simcenter STAR-CCM+ is part of the Accelerator portfolio, can be coupled to other analysis and PLM tools. For this presentation, we're going to focus on the third pillar for achieving faster workflows. There's been a number of new capabilities added to STAR over the past year since the 2310 release that allows the user to take advantage of new automation capabilities and reduce the time for pre-processing and model setup. 2310, Siemens introduced the automation node to STAR-CCM+. This feature now contains commonly used nodes for model parameterization on automation. Before, these nodes were located way at the bottom of the simulation tree, spread out under the Tools node. This level of reorganization greatly reduces the time spent scrolling down, searching for these nodes, and makes you a more productive simulation engineer by reducing the prep time. You may have also noticed there's a new node in this list, Stages. Stages is a new feature that was introduced in 2310, which will greatly extend automation capabilities. With Stages, we can use a single model to set up different configurations of the simulation. The user can create as many stages as they want, and each stage can define its own set of physics and boundary conditions. Stages can also be coupled with simulation operations to automate switching between the defined stage variants for a complete end-to-end workflow. This new feature eliminates the need for developing custom Java macros and greatly improves user workflow. Here's a short demo showing a strong application for stages with a transient thermal analysis. We have an insulated chilled water tank that's exposed to solar radiation and outside temperatures. Normally, chilled water enters and exits the tank at a set cool temperature, but we'd like to simulate the response to a step temperature increase. To get the initial conditions for the transient thermal analysis, we first need to run a steady-state thermal analysis at the nominal conditions. This is where Stages can help us automate this process. First, we'll go over to our stage node and create two new stages that we will rename Steady and Transient. We'll now go to our stage tree, and what we want is the steady stage. Make sure all the physics models that we have defined is set to the steady time domain. Now that we've ensured they are defined at the steady time domain, we will go and grab the inlet temperature for the inlet node. We want that to be a constant inlet temperature at the nominal temperature. For the transient domain, we're going to switch this to a field function that ramps the inlet temperature. We're also going to go back to all the physics models that we have defined and switch the time domain from steady to implicit unsteady. So we now have those two stages set up, and we will use simulation operations to automate the workflow. Under simulation operations, we're going to create a couple steps that will set the stage. First, set the steady set stage, and then we will solve the physics. We will set the transient stage and solve those physics. And once we have all those physics solved, we can run the simulation operations, and we have a fully automated end-to-end workflow for this two-step simulation showing the incoming hot fluid dispersing through the tank. The last feature we will discuss, this was also added in 2310, concerns the inline addition of parameters and field functions. No longer do you need to plan ahead and create a scalar parameters for boundary conditions or field functions. You can now create those definitions at the point of use. This will save time as you no longer need to stop, define the parameters, and then return to the boundary or function that you're trying to define. Here we have an example of this feature with the function expression editor, where we'll create a simple temperature ramp function similar to what was used in the previous analysis. This function will linearly ramp the inlet temperature from a nominal set point to a final elevated time. We will require three parameters for this ramp time, a high temperature and low temperature set points. As we start typing out the function, we can create each scalar parameter, define this point at this point of use, define the parameter name, the dimensions, and the value. All of these scalar parameters will now show up under the automation node and can be accessed by the user to change values for a future simulation. The goal with these improvements is to make a more user-friendly environment and increase your productivity with STAR. Reduced time for simulation setup and increased end-to-end workflow automation will allow you more time for simulation exploration to achieve superior product designs and get to market quicker. Thanks for your time from Applied CAX.